Hello everyone. Today we are going to start basic subject introduction of compiler design. Subject code is 2170701. First, what is compiler? Why we used compiler? What are the features of compiler? Compiler is a computer program which helps you transform source code written in a high level language into machine language. If there is any error in your source code, then it generates the error. So compiler is nothing but it is a translator which translates one form to another form, source code to target code. First, compiler design is a basic core subject of computer engineering. It teaches how compiler of a programming language works. It also focuses on various design of compiler and structuring and optimizing various phases of compiler. It is also necessary to learn types of grammar, finite state machines, Lex, Yak and other concepts which you already learned in theory of computations. So what is the teaching and examining scheme of compiler design? There are 6 credits for compiler design, 4 lectures and 2 practicals. At the end of semester you have a 70 marks external examinations, theory examinations, 20 plus 30 your mid semester marks, 30 marks external practical examination and practical evaluation internal is 20. So there is total 150 marks. Reference books for compiler design is Compilers, Principal, Techniques and Tools by Aho, Ullman and Sethi, which is the best reference book for compiler design. It covers most of your subject, near about 90% of your subject is covered in this reference book. You can use any e-books or any reference books related to your subject. So first, what are the features of compilers? That is correctness, speed of compilation, preserve the correct, the meaning of the code, speed of the target code, recognize legal and illegal program constructs, good error reporting or handling, code debugging help. These all features in compiler. So we used compiler for any language translate. Types of compiler: there is single pass compiler, 2 pass compiler, multi-pass compiler, cross compiler, etc. In a single pass compiler, source code is directly transformed into target code or machine code, wherein 2 pass compiler it divide into 2 sections. First, source code is passed to front end and it generate intermediate representation. Then after intermediate representation passed to back end which generates the target code. In multi-pass compiler, source code passed to front end which generates intermediate representation, which is passed to middle end which generates intermediate representation, and passed to back end. All these front end, middle end and back end generates error, then generates the machine code. Tasks of compiler: main tasks performed by the compiler are breaks up the source program into pieces and impose grammatical structure on them, allows you to construct the desired target program from the intermediate representation and also create the symbol table, compiles source code and detects errors in it, manage storage of all variables and codes, support for separate compilation, etc. There are total 8 units in your syllabus. First one is introduction. In introduction part, first is overview of the translation process. In the translation process, source code is converted to target code using any of translator. Translator is either compiler, interpreter or assembler. We show that compiler is a program that translates source code to target code, while interpreter is also a translator which translate source code to target code. Then what is the main difference between compiler and interpreter? Compiler takes entire program as an input, while interpreter takes single instruction as an input. Assembler converts assembly language code to target code. Linker and loader. Linker helps you to link and merge various object files to create an executable files. All these files might have been compiled with separate assemblers. Loader. The loader is a part of the operating system which performs the task of loading executable files into memory and run them. Types of compiler we already discussed: single pass, multi-pass, two-pass compiler. Then analysis of source program, phases of compiler. Phases of compiler, there are different 6 phases of compiler. First one is lexical analyzer, second is syntax analyzer, third semantic analyzer, fourth intermediate code generator, fifth code optimizer, and last one is code generator. Source code is passed to all these phases of compiler, then after it generates the target program. Symbol table and error detection and recovery are together with all the phases of compiler. Symbol table is a data structure used by a language translator such as a compiler or interpreter for storing names encountered in the source program along with its relevant attributes and names. Phases of compiler are divided into two parts, front end and back end, or analysis and synthesis phase. Analysis phase consists lexical analyzer, syntax analyzer and semantic analyzer as a front end. Then after it generates intermediate code generator and it passes to back end, which is synthesis phase. It's considered code optimizer, code generator. Then after finally generate the target program or target code. So these all are the phases of compiler, front end and back end of compiler, or analysis, synthesis, model of compilation. Then after pass structure, then what is the pass? What is the difference between pass and phase? Pass refers to the traversal of a compiler through the entire program. There are two types of compiler according to pass: single pass compiler and multi-pass compiler. While phase of a compiler is a distinguishable stage which takes input from the previous stage, processes and yields output that can be used as input for the next stage. Next unit is Lexical Analyzer. Then first, what is Lexical Analyzer? It is the first phase of compiler. The main task of Lexical Analyzer is to read the input characters and produce as output a sequence of tokens that the parser uses for syntax analysis. What is token? Token is a sequence of character having a collective meaning. Typical tokens are identifiers, keywords, operator, special symbols, constants, etc. Lexeme is a character sequence forming a token which is known as lexeme. Input buffering. The speed of lexical analysis is a concern in compiler design. So there are two buffering techniques, buffer pair and sentinels. Because of the amount of time taken to process characters and the large number of characters that must be processed during the compilation of a large source program, specialized buffering techniques have been developed to reduce the amount of overhead required to process a single input character. So these input buffering techniques are used. Next one is specification of tokens. In that, prefix, suffix, substring, subsequences, these all terms are used. Then operation on languages, there is union, concatenation, clean closure, positive closure, these all are used. Recognition of tokens. In this, any statement is given like if expression then statement, or if expression then statement, else statement, or epsilon, then gives expression gives term reloop term or term, and term gives id or number. So according to this grammar, you have to use language generated by grammar, which we already learn in theory of computation. Finite automata. From a regular expression, you have to draw finite automata according to regular expression. Then after, draw DFA, transition diagram. Then what is transition diagram? It is a stylized flowchart. Positions in a transition diagram are drawn as a circle, or it is known as states. States are connected by edges, which is shown using arrow. Then after, draw DFA and optimization of DF. Next unit is parsing theory. In parsing theory, there are top-down and bottom-up parsing algorithms. In the top-down parsing techniques, process is done from root to child, and bottom-up parsing technique, process is done at child to root. Then operator precedence parsing techniques give the precedence to each and every operators like less than, greater than, equal to. Then LR parser, which is SLR, CLR and LALR. simple LR parsing technique, canonical LR parsing techniques, and look ahead LR parsing techniques. Then using ambiguous grammar. And what is ambiguous grammar? You can generate more than one parse tree from the single grammar, parcel generated, then automatic generation of parser, syntax directed definition, construction of syntax tree. Syntax directed definition is a generalized of context free grammar in which each grammar symbol has an associated set of attributes. Types of attributes are synthesized attribute and inherited attribute. Then what is synthesized attribute and what is inherited attribute? So value of synthesized attribute at a node can be computed from the value of attributes at the children of that node in the parse tree, while in inherited attribute, values of the inherited attribute at a node can be computed from the value of attribute at the parent and or sibling of the node. In synthesized attribute, pass the information from bottom to top in parse tree, while in inherited attribute, pass the information top to bottom in the parse tree or from left sibling to the right siblings. Then dependency graph. So what is dependency graph? The directed graph that represent the interdependency between synthesized and inherited attributes at node in the parse tree is called the dependency graph. Then what is L attributed definitions? A syntax directed definition is L attributed if each inherited attribute of any x of j, then 1 is less than equal to j, less than equal to n on the right side of any production, depends only on the attributes of the symbols to the left of any products. Then second one is inherited attribute of a. Then syntax directed definitions and translation schemas. Then attributes are used to evaluate the expression along the process of parsing. Next is error recovery. Error can be classified into mainly two categories: compile time error and runtime error. Compile time error are generated during the lexical analyzer or syntax analyzer or semantic analyzer. Lexical errors are like any spelling errors or invalid tokens. In syntax error, there are mainly errors in structure, missing any operators or any unbalanced parenthesis, while in semantic errors there are any incompatible type of operands or any not matching of actual and formal arguments or any undefined variable. There are mainly 4 types of error recovery strategies or ad hoc and systematic methods, which are panic mode, phrase level recovery, error production, and global correction. Next unit is intermediate code generation. Then what are the role of intermediate code generation? In the analysis synthesis model of a compiler, the front end translates the source program into an intermediate representation from which backend generates the target code. Different intermediate forms are abstract syntax tree, postfix notation, 3 address code. There are 3 different types of 3 address code. First one is quadruple, second is triples, and third one is indirect triples. In quadruples is a structure with at most 4 fields such as operator, argument 1, argument 2 and result, while in triples avoid entering temporary names into symbol table. So there are only 3 fields: operator, argument 1 and argument 2. Third one is indirect triples, in which listing of triples has been done and listing pointers are used instead of using statement. In syntax directed translation mechanism, for obtaining the 3 address code and the SDD translation scheme, all semantic rules must be written for each source code statement. There are various programming constructs for which the semantic rules can be defined. Using these rules, the corresponding intermediate code in the form of 3 address code can be generated. Various programming constructs are used like declarative statement, assignment statement, arrays, boolean expressions, control statement, switch case and procedure call. Next unit is runtime memory management. First one is source language issues. There are different issues in source languages like procedure call, activation tree, control stack, scope of declaration, binding of names. Then next is storage organization. So first one is subdivision runtime memory, second one activation records, and third is compile time layout of local data. These 3 methods are used in storage organization. So static and dynamic memory allocation. Static memory allocation, memory is allocated before the execution of the program begins, while dynamic memory allocation is a memory is allocated during the execution of program. Then storage allocation strategies. The different storage allocation strategies are static allocation, stack allocation and heap allocation. In static allocation, layout storage for all data objects at compile time, while in stack allocation manages the runtime storage as a stack, and in heap allocation allocates and deallocates storage as needed at runtime from a data area known as heap. In parameter passing methods, there are 2 types of parameters: formal parameters and actual parameters. Based on these parameters, there are 4 parameter passing methods which is generally used. First is call by value, second one is call by reference, third copy restore, and fourth is call by name. Then symbol table and language facilities for dynamic storage allocation. Then what is symbol table? Symbol table is a data structure used by compiler to keep track of semantics of a variable. That means they stores the information about scope and names, which is built during lexical and syntax analyzer of phases. Dynamic storage allocation techniques. There are mainly 2 types of techniques are used in dynamic storage allocation. First one is explicit allocation and second is implicit allocation. Next unit is code optimization. First one is global data flow analysis. Data flow equations are the equations representing the expression that are appearing in the flow graph. Data flow information can be collected by setting up and solving systems of equations that relate information at various points in a program. A few selected optimizations like command sub expression removal, loop invariant code motion, strength reduction, etc. In command sub expression removal, the very common sub expression appearing repeatedly in the program which is computed previously. If the operand of this sub expression do not get changed at all, then result of such sub expression is used instead of recomputing it each time. In loop invariant code, it can be obtained by moving some amount of code outside the loop and placing it just before entering into the loop. Strength reduction, strength of certain operators is higher than others. For example, the strength of multiplication is higher than plus. So, change the operator. Actual calculation of any method does not change. This like few selected optimization techniques are used. Last unit is code generation. Code generator is the final phase of compilation process. It takes an intermediate representation of the source code as input and produce an equivalent target code as output. Target code should have the following property. It should be a correct, high quality, efficient use of resources. Then quick code generation. Issues in the design of a code generators are the target machine, runtime storage management, memory management, instruction set selection, basic blocks and flow graphs, simple code generator, register allocation and assignment. Then the DAG representation of basic blocks. Then what is DAG? It's a directed acyclic graph. The directed acyclic graph is used to apply transformations on the basic blocks. A DAG gives a picture of how the value computed by each statement in a basic block used in a subsequent statements of the blocks. Peephole optimization. What is peephole optimization? Peephole optimization is a simple and effective technique for locally improving target code. This technique is applied to improve the performance of the target program by examining the short sequence of target instruction and replacing these instructions by shorter or faster sequence whenever possible. Peephole is a small moving window on the target program. Characteristic of peephole optimization: redundant instruction elimination, unreachable code, flow of control optimization, algebraic simplification, reduction in strength and machine idioms. These all are the characteristic of peephole optimization. So these 8 units are in compiler design and total subject marks are 150. According to weightage of each and every unit, Distribution of theory marks are listed here. R level, U level, A level, N level, E level and C level. R means remembrance, U means understanding, A means application, N means analyze, E means evaluate, C means credit. So these are the revised Bloom's taxonomy. This specification table shall be treated as a general guidelines, not that the actual distribution of marks in the question paper may vary slightly from this table. So it is not compulsory that each and every theory portion will be strictly distributed according to this level, but almost nearly about to this revised Bloom's taxonomy level. So this is the basic subject introduction of compiler design. Subject code is 2170701 and total credit is 6 and total marks is 150. Thank you.